Namaste dosto. Imagine you have a beautiful triangle, but this time you don't know its height. How do you find the area then? Usually, to find the area of a triangle, we need the base and height, right? But what if the height is missing? Arey vah! That's exactly when Heron's formula comes in handy. So, what is Heron's formula? It's a clever way to find the area of any triangle when you know all three sides, but not the height. Suppose the sides of a triangle are A, B, and C. The first step is to find the semi-perimeter, which we call S. And what is S? It is half of the perimeter, the sum of all sides divided by 2. In other words, S equals the sum of a plus B plus C divided by 2. Now, here comes the magic formula for the area. The area is equal to the square root of S multiplied by the quantity S minus A times S minus B times S minus C. Let me say that again slowly. Area equals square root of S times open bracket S minus a close bracket times open bracket S minus B close bracket times open bracket S minus C close bracket. This formula makes life so much easier since we don't have to calculate the altitude or any angles at all. And the best part, it works for all types of triangles. Whether the triangle is scalene, isosceles, or equilateral, Heron's formula always gives you the correct area. Picture this, a triangle with sides labeled A, B, and C. You can imagine calculating the semi-perimeter and plugging those values right into this formula to get your area straight away. So, next time you face a triangle puzzle without a height, remember, Heron's formula is your best friend. Now that we have the formula, you might wonder, how did Heron come up with this formula? Let's take a deeper look at the math behind it. Consider triangle ABC with sides A, B, and C. From vertex C, we drop a perpendicular height h onto the base hub. We know the area of a triangle is half the product of base and height. But there's another way to find the area. Half times a times b times sine of angle C. To connect the sides without involving angles directly, we use the cosine rule, which says that cosine of angle C equals the quantity a squared plus b squared minus c squared, all divided by 2 times a times b. Now, here's a cool trigonometric identity. Sine squared of C equals 1 minus cosine squared of C. Using this, we can express sine of C fully in terms of A, B, and C. By substituting these values back into the area formula and simplifying step by step, we finally arrive at the elegant expression for area as the square root of S times S minus A times S minus B times S minus C. That is, the very same Heron's formula we saw earlier. Imagine the diagram that shows the triangle with height h and all sides and angles labeled carefully. This helps us visualize the whole derivation. Isn't it amazing how trigonometry and algebra come together to give us this neat formula? Now you're all set to use Heron's formula. Let's go through the step-by-step method clearly. Step 1. Find the semi-perimeter S, which is the sum of the three sides divided by 2. So, S equals a plus B plus C divided by 2. Step 2. Compute the area by plugging S, A, B, and C into the formula. The area equals the square root of S times S minus A times S minus B times S minus C. Remember, when calculating the square root, be careful to get accurate values. Sometimes you'll want exact answers, other times decimals rounded to 2 places. Always double check that the units of your side lengths are the same before starting to keep the area units consistent. This method is especially useful in geometry problems where you know all the sides but the height isn't given. No need to draw perpendiculars or measure angles. Picture a triangle with sides A, B, and C labeled, showing the semi-perimeter value and the area formula clearly annotated. This visual makes it easier to remember. By following these simple steps, you can calculate the area of any triangle confidently. Shabash. Arey vah. Let's try a solved example to see Heron's formula in action. Suppose we have a triangle with sides 7 centimeters, 8 centimeters, and 9 centimeters. Our goal: find the area using Heron's formula. First, calculate the semi-perimeter S. So S equals the sum of 7 plus 8 plus 9, all divided by 2. That makes S equals 24 divided by 2, which gives us 12. Next, plug values into the formula. Area equals square root of 12 times open bracket 12 minus 7 close bracket times open bracket 12 minus 8 close bracket times open bracket 12 minus 9 close bracket. Let's calculate inside the brackets. 12 minus 7 is 5, 12 minus 8 is 4, and 12 minus 9 is 3. So area equals square root of 12 times 5 times 4 times 3. Multiplying inside the root, 12 times 5 is 60, times 4 is 240, and times 3 is 720. Finally, area equals square root of 720, which is approximately 26.83 square centimeters when rounded to 2 decimal places. Imagine the triangle labeled with sides 7 centimeters, 8 centimeters, and 9 centimeters. It really helps to visualize everything. Excellent, Beta. You've just calculated the area of a triangle without needing to know its height. Let's try another example, this time with an isosceles triangle, 2 equal sides and a different base. We have a triangle where 2 sides are 10 centimeters each, and the base is 12 centimeters. The challenge: find its area without knowing the height. Step 1. Calculate semi-perimeter S, which is the sum of 10 plus 10 plus 12 divided by 2. That is 32 divided by 2, giving S equals 16. Step 2. Compute area with Heron's formula. Area equals square root of 16 times open bracket 16 minus 10 close bracket times open bracket 16 minus 10 close bracket times open bracket 16 minus 12 close bracket. Evaluate inside the brackets. 16 minus 10 equals 6, again 6 for the second, and 16 minus 12 equals 4. So area equals square root of 16 times 6 times 6 times 4. Multiply these. 16 times 6 is 96, times 6 is 576, times 4 is 2304. Finally, area equals square root of 2304, which is exactly 48 square centimeters. Visualize that isosceles triangle with the equal sides labeled 10 centimeters and the base 12 centimeters. Notice no height is drawn, but we still found the area. This shows how Heron's formula is very useful even when the altitude cannot be measured directly. Great job paying attention here. Now, let's tackle a scalene triangle where all 3 sides are different. Given sides are 13 centimeters, 14 centimeters, and 15 centimeters. We'll use the same process to find the area. Step 1. Calculate semi-perimeter S is equal to the sum of 13 plus 14 plus 15 divided by 2. That's 42 divided by 2. So S equals 21. Step 2. Plug into Heron's formula. Area equals square root of 21 times open bracket 21 minus 13 close bracket times open bracket 21 minus 14 close bracket times open bracket 21 minus 15 close bracket. Simplify inside the brackets. 21 minus 13 is 8, 21 minus 14 is 7, and 21 minus 15 is 6. So area equals square root of 21 times 8 times 7 times 6. Calculating the product. 21 times 8 equals 168, times 7 equals 1176, times 6 equals 7056. Finally, area equals square root of 7056, which comes to exactly 84 square centimeters. This example confirms that Heron's formula works perfectly for any triangle, scalene, without equal sides. Try to picture the scalene triangle with the 3 distinct side lengths labeled to reinforce the idea. Arey wah! You're mastering Heron's formula like a pro. Let's quickly summarize what we learned about Heron's formula today. First, remember the semi-perimeter formula. S equals a plus B plus C divided by 2. Then, the area formula. The area equals the square root of S times S minus A times S minus B times S minus C. This formula comes from applying the cosine rule and trigonometric identities, cleverly eliminating the need for height or angle measurements. Key ideas. It works for all triangle types, whether scalene, isosceles, or equilateral. It's incredibly useful in mensuration, geometry problems, and many real-life situations where exact heights are hard to measure. One last tip. Always keep your units consistent when calculating and simplify square roots when possible. सोच के देखो. Heron's formula saves you time, simplifies complex problems, and is a great tool for your math toolbox. Keep practicing. You will ace those exam problems with confidence. Shabash beta.